See, here is a good concept based on the angular velocity of two particles. One particle is revolving with a speed v1 in a circular orbit of radius r1. Another particle of is moving with the speed v2 and in a circle of radius r2. At an instant of time, the angle between two vectors, radius vectors, is given by theta. Now the problem is, what is the angular velocity, relative angular velocity between these two particles if they are rotating in different circles with different constant speeds. Suppose they are rotating in xy plane. Now here see, we know the relation between linear velocity in terms of angular velocity is v2 minus v1 is omega, and it is cross r2 minus r1. It is the relative velocity, relative separation, and it is the relative angular velocity. So in this case, and once again one more formula from vector triple product, a bar cross b bar cross c bar is equal to a dot c my b bar minus a dot b a bar dot b bar c bar. So if you substitute from this equation, and here r cross v2 bar minus v1 bar means r2 minus r1 cross, and in place of v2 minus v1 we should substitute this value, and it is in the form of a bar cross b bar cross c bar. And if you expand this equation as per this one, then you get finally, here see, r2 minus r1 dot r2 minus r1 bar is equal to, it is r2 minus r1 whole square, and here angular velocity is normal to the plane of r2 minus r1. Then the dot product of these two is equal to 0, so this term will become 0. And from this equation, angular velocity is rewrite as r2 minus r1 cross v2 minus v1 upon r2 minus r1 whole square. And if you simplify it, then you can get the angular velocity is this one. And here, and after simplification, r2 cross v2 bar is r2 v2 sin 90 equal to 1, and here this one also r1 cross v1 is r1 v1 sin 90, this one, and here r1 cross v2 means r1 cross v2 r1 v2 sin theta is the angle between r1 and v2. Here it is r1 and it is v2, then this angle is 90 minus theta, so sin of 90 minus theta becomes cos theta. And here r2 cross v2, r2 cross v1 bar means you can write r2 v1 sin, the angle between those two vectors is here v1 and r2, this angle is 90 plus theta, sin of 90 plus theta. And here sin 90 minus theta cos theta, sin 90 plus theta cos theta. By substituting and taking the common of cos theta, this is the general formula for relative angular velocity between two particles are revolving in different circular path with constant speed. So there are two special cases. If theta is equal to 0, both particles are in same line, then relative angular velocity is, by substituting theta is equal to 0 from this equation, we get omega is v2 minus v1 by r2 minus r1. If theta is equal to 180, these two particles are opposite to each other, then relative angular velocity is, v2 minus v1, v2 minus up minus v1, and it is separation between these two is r1 plus r2. So here this is the relative angular velocity when angle between those two is equal to 180. Relative angular velocity when angle between those two is equal to 0.